So last time we covered some of the basic functions. Let's revisit those quickly, just so we're refreshed, and then we'll move forward from there. We covered future value equals FV. What are the parameters for future value? Somebody, anybody? Excellent. What's the caveat? What do you need to be aware of when using future value? What does Excel expect? Present value is negative. Excellent. If your payment is a withdrawal, money coming to you, what sign will that be? I think I heard positive. I agree. If your payment is a payment, an expense, what sign would that be? Good. Negative. That's important. The other one was present value equals PV, same parameters, rate, number of periods, and possible payment, possible future value. What do you need to remember about that one? Same thing, the sign. The future value of a series of payments, Excel expects that this is money that you are investing, so it's assuming those payments are going to be negative, and then it will return a positive future value. Think of it in terms of you're putting money into the bank, and at the end you have this lump sum. And we talked about the PMT function, payment. Another word for payment for this class purposes is, excellent, annuity. And what are the parameters for annuity? For payment. Right. They're all the same. Rate, time period, some present value, some future value. So we kind of covered that, but I want to cover it a little more in depth today. Converting something to a series of payments is simply saying, look, I've got this lump sum, I'm going to use this. I have 100 drinks of Rockstar in here, right? This can represents present value of the contents of this can. If I portion it out into 100 little cups and had 1 cup a day, are those two equivalent? 1 can or 100 little cups? Yes? Yeah. That's all payment is. It's taking something that has a lump sum value and converting it into equivalent values. The only difference in our class is we have to factor in interest. So you can't just take the can and divide it up into 100 equal portions. We have to assume that through the magic of science that it's going to grow a little bit along the way due to the inflation of Rockstar. That make sense? All right. The terminology is uniform equivalent annual cost or annual value. So if I wanted the uniform equivalent annual cost of something, what I'm really asking you is, what's the payment value? Take this lump sum and convert it into an equivalent cost. And a payment, as we defined earlier, is a consistent value over a consistent period of time. Uniform, equivalent, annual cost. Good? So why is that important? One of the things we looked at was taking unequal time periods and using the assumption of repeatability. If you can repeat the process, you don't have to find the present worth, you don't have to use least common multiple, you can simply find the annual cost of that project. I can find the annual cost of a 5-year project, and the annual cost of a 7-year project, and the annual cost of a 9-year project, and compare it. I don't have to find the least common multiple of 9, 7, and 5, which would be, well, let's see, 9, 7, and 5 are all prime, so I think you're going to find that it's 9 times 5 times 7 to get, and I don't think you want to drag down, what's that, close to 350 cells? See how I did that in my head? Crazy smart. Rockstar. I should be getting paid from Rockstar for this. This should be like, all right. So what I'm going to show you on Excel, one of the things I want to show you today is why that works. But the truth of the matter is, if I find the annual cost of a 5-year project, that annual cost is the same no matter how many times I repeat it. Because all we're doing is we're taking that one down arrow, that present value, those payments that we're going to receive plus any future value that we might get, and we're going to repeat that over and over and over. So when I convert that into a payment, nothing changes. It's still a payment. We're just extending the time period. So if you have unequal lives on your final, you think you might have that? If you have that, you can find the least common multiple, or you can find the payment value of that project and compare it. Save you a lot of time. All right, so let's, okay, so that was present value, future value, payment. We covered rate. How do you find rate? Anybody on rate? Rate function. Yeah, rate function. What does it expect? I'll just put it up here. Number of periods. Say again?
Is there any way you focus the strings into the floor? I can't agree or just put myself.
It's not any better, is it? So all the hype about HDMI and VGA is really total crap. I don't know what to do about that.
Yeah.
So the rate requires a number of periods, some payment value, some present value, and potentially some future value, and it will return the rate. Again, it's critical that your present value is going to be a negative value. This is what you're putting in, and what you'll get out would be a positive value, and it'll return the rate that makes that statement true. Did we cover IRR? You guys only had a couple of problems in IRR, so I don't know that you'll see it on the final. But if you do, IRR is actually just as easy as using the net present value that we talked about. Here in column C, I just listed some random values there. So I've got a cost of $45,000, $450,000 up front, and it looks like a cost in year 1 and some income, 2, 3, 4, another cost in year 5, and then down in year 6, I calculated the IRR. It's as simple as equals IRR and grab those cells. That's it. And that'll give you the actual rate of return for that. Good? I have no idea what you're saying. For those of you out in camera land, Cookie, what's going on?
It'll be there. So it'd be very nice if you solve a problem using IRR.
IRR will be there. Okay, excellent. So, the difference between this one and net present value, you will not include your times 0 values in the calculation. You need to add those to what net present value returns. Remember covering that last week? Net present value calculates the values from year 1 through each year that you've selected. It goes in order. It doesn't care how you label your cells. If you label them 1, 3, 5, 7, 9, it will think that that means 1, 2, 3, 4, 5. So you need to list all the years. Select all of them but 0, then add year 0 to it, and that's your present value. With IRR, you need to select all of your values. it expects that the first value is present value equals 0, and then adds from there. And can you see the formula there? Equals IRR with the cell range of C2 through C7. That's it. And it returns back the percentage that is the IRR. So it's not a bad function. I mean, if you're asked to solve IRR, then obviously you'll need it. It's also a quick, easy way to see if one project is feasible. What if my MAR was 25% and the IRR is 24%? What do I know already? Exactly. The IRR is less than the MAR, it's out. I'm done, I can move on. And we covered net present value. And so I'm going to take IRR out of here, just for fun. We're going to cover it again. Because this really is just such a convenient function. A lot of times you're going to have values that are not considered a payment because the income varies over the course of time, or it increases at some rate. So you can't just use the present value or future value function. And the net present value is just, well, it's just too easy. N equals NPV, some rate. We're going to assume 10%. And then a series of values. I'm grabbing from 1 through 15. And then I'm adding in my present value at time 0. And I don't know why it likes to give me a percentage all the time. $31.17. That doesn't seem right, but I'm going to have to trust that it's right. Doesn't seem right. But assuming that is right, and this were a project we were evaluating, what would you tell your boss? Yes? No? I see a lot of yeses. Anybody say no? Excellent. You've learned well. Why is it a good idea? You know to say yes, but you don't know why? Yes?
Because the revenues are greater than the expenditures.
Okay. Simply put, the revenue is greater than 0. And I put in 10%, which means I'm expected to make 10%. What if the revenue was exactly 0? Then what would you say? Well, boss? What?
It's up to you.
It's up to me. Okay. Why am I paying you then? Why are you here? Anybody? Better than it's up to me? All right. The answer is yes. We still go ahead. At 0, it means we made exactly 10% on our investment. We put in 10% for a MAR. If the present value is 0, we made exactly 10%, which was our target. So if it came up -1 for the class, we're going to say no. Pretty hard and fast. For real life, when we go back to our boss and say, yeah, we're looking at probably 9.99% rather than 10. Then we evaluate based on the risk. Make sense? So 0 does not mean you made $0. Yes, go ahead.
Doesn't the alternative also offer you to make 10% on your money?
Yes.
So,
But the alternatives, what you guys have been doing for an alternative is really just a way of choosing the MAR. So Cookie gave you some real life, hey, I can put my money in the bank and make this. Or I've got an investment opportunity where I know I'm going to get this. And if that's the case, then you're not going to go for 9.99 when you know you can make 10. Even though it's only a 0.01 difference.
would you go for, you said, would you still go for 10 in the project, even if you can get a guaranteed 10 from the alternative?
Probably no. If it was underneath that and I had a guarantee, then I would go with my guarantee.
Okay.
So for class purposes, it's really hard and fast. You know, if it's 0 or above, you're going to say yes. If it's negative, you're going to say no. It's just that simple. If you guys end up doing any kind of financial analysis out in the real world, there's some other risk factors that you want to take into consideration. Is all I'm saying. Okay. IRR, pretty easy, right? So we did FD, PV, payment, net present value, rate, and IRR. That's pretty much the bulk of the functions. I can't imagine we didn't need anything else besides that. So let's put them to work. Let's put you to work. All right, 486. The geometric gradient has a positive cash flow of $1,000 at end of year 0. It increases 5% per year for the following 5 years. Another one, positive $2,000 at end of year 1. Decreases by 6% per year for years 2 through 5. At 10%, which of those two do you choose? You can use any of the functions that we've talked about. So because the one increases and the other decreases, you would not be able to use the future value, the FD or PV function. Somebody tell me why not?
Have a continuous payment.
Excellent. Payment changes by a gradient, can't use those functions. Is the IRR function helpful here? See a no? Maybe. What if you found the IRR of that and found that it was less than the MAR? What would that tell you? You could reject it. So perhaps the IRR is helpful. Rate we're given, so the rate function is not really helpful. What function is probably the most helpful here? Yeah, I suppose you could convert that to a payment function. But you have values each year. How would you incorporate that into the payment function? What's my favorite function? NPV, net present value. And since we're only talking years 0 through 6 and 0 through 5, that's not that much. It's not like you're dragging down through 35, 40 cells. Anybody have an answer? The $2,000 declining? What'd you get? How did you solve
NPV.
it? Using the MPV function? Anybody else solve it? also used NPV? Okay. Anybody else saw the difference? No. All right, let's take a look. Here's how I laid this one out. Here's my years, 0 through 6. It said $2,000 at end of year 1, so I have nothing in year 0. And it says it decreases by 6% each year. So I put the 6% here, and then I subtract 6% from the previous value, and put it in year 2. Does that make sense? So my payment's decreasing by 6% per year. Then down at the bottom, I simply did the net present value of that series, 1 through 6. Notice I did not include year 0, nor did I add anything from year 0 to it, because there is no value in year 0. Make sense? Then on the other side, it said I started with $1,000 at year 0. That's the same as saying I put $1,000 in the bank today. And then a year from today, I'm going to put in $1,050. Or maybe Cookie hands me $1,000 for exceptional TA today.
Today. I'll give you a can of Rockstar if you're interested.
And that one said it went through years 5, increasing by 5%. All right, let's test my theory. If I wanted the IRR, we need to include a 0 for year 0, equals IRR, for these values. Uh-oh. Oh, there's no negative for time 0. I lied. I do that sometimes. So, I guess not. In another situation, you can use IRR, but without a value, without a payment at the beginning, it's going to return invalid number. All right, we good on that? Click on the NPV cell. It's equals NPV. You need to give it a rate, which is the C3 value. Or you can type in 10%. Or you can type in 0.1. And then I select the range of cells. Do not select the year 0. Net present value takes everything back to 1 year before the start date. So if you select year 0, it'll take you back to the year before year 0. Does that make sense? Cool. Yes. Cell H. H8. That's just. Oh, okay. So all I'm doing is taking the previous value plus 5% of that value. I could have easily done 1,000 times 1.05 by adding 5%, but I just wanted to show it in the column where those values are coming from.
I'm getting a different value for that.
Oh, did I screw up?
Yeah. Maybe.
Okay, so. Oh, I used the wrong percent value, didn't I? somehow I referenced the 6% rather than the 5%. Do those values look better now? My apologies. So you can employ this NPV trick or function. I mean, if you have all sorts of wild values, this is going to be the one that's going to be your best bet. What if I wanted the annual value of these guys? What if you had one of those least common multiple problems? 3 years, 4 years, 5 years. And it didn't fall into the category of being able to use PV, FV, or PMT. You could use NPV to find the present value of each one individually. Then, using the PMT function, you can convert that present value into an annual value. So what we did right here, we found the net present value of this 7-year project, or this 7-year cash flow. If I want to convert that into an annuity, equals payment, T. There's my rate. Number of periods is 6. And my present value, where it needs to be a negative value, I'm going to use that value right there. That one I just calculated. So how we talked about cutting my can up into 100 little portions? We're saying that cash flow of getting $2,000 now or a year from now, they're getting 6% less than that every year for years 2 through 6, is the same as having $7,600 in your hand right now, and it's the same as having $1,700 given to you every year. All three of those things are equivalent. So I plugged in the rate, number of periods, 6 years, and I took that present value and I inserted it as a negative value. So we have two unequal life projects here. I mean, the book doesn't call it project, but it can certainly be one. But if we could assume that we're going to repeat this process, that this continues on and on, then we could compare them using present worth, or the payment. This one is 5. It's negative 10. So that'll be handy for you, because I'm pretty sure you'll see something with these common multiple. So find the present worth of each one individually and convert it to a payment. When you do convert it to a payment, remember to use the appropriate number of years for each project. You can't just magically assume that one goes from a 5-year to a 6-year. Yes?
Can you show the equation for that? The one that your cursor's on? No, the other one. The highlighted yellow NPV even.
The highlighted yellow, that's the net present value.
What did you add to it?
The value at year 0. Did I do this one wrong too?
Looks correct.
Wow, yeah. Oh, I dragged that across. That's good. Yeah. That's exactly correct. Have we corrected all my mistakes? There's some that say that instructors do that on purpose because it helps you learn. I did not do that on purpose. I just carelessly dragged across, and I didn't line my years up. Notice on my zeros on row 6 on one and row 5 on another, that's sloppy. I'm ashamed of myself. I'm amazing. My life is perfect. You guys know how many days it is till school's out? Are you counting down days now? I'm gonna start counting down hours, I think. I might even write an Android script that reminds me every hour.
Show off.
Long road. Okay, we feel pretty comfortable and confident with using net present value and then what we can do with it from there. What if I wanted the future value of these things? For some reason. Could I use my net present value to start and then calculate a future value afterwards? Absolutely. Once I have a present value, I can convert it to a payment or convert it to a future value. Yeah, I think you'll find it really handy. So how about, I don't think we did 490.
I have a question.
Yes.
What number was this problem again? Like what problem?
In the book, it is problem 4-86.
Okay, the
And
value
that's
is
a 15th edition, not 16th.
486, you said?
486.
Okay. And the value that's under your cursor, what is it?
That is the net present value of that second cash flow.
What was the problem statement again? What are all those values? Like, that's gaining with 5% and negative 6%? What is the problem asking again?
$486.
Okay, so it's saying you receive a revenue of $1,000 times 1 plus 5% to the end, like each year. So each year you just get a bigger revenue, like a
Yes, but not 1 plus 5 to the end.
No.
It's just taking the previous value and increasing it by 5. Let's do the next one.
Okay.
It's a similar problem, and it'll look, it might be a little more expensive. So 490. She's 22. That's important. She's newly hired. She's a marine biologist. Admirable. They don't make a lot of money. It's unfortunate. She wants to retire. So Amy's contribution plus her employer is $2,200 per year starting at age 23. So that's why the 22 is important. She's 22 now. Starting a year from now, she's going to put $2,200 a year away. So right off the bat, before I go any further, I know that in my year 0, I have 0. I've got nothing, right? And in year 1, I have what? Positive or negative? Good, negative. And she expects to increase this amount by 3% per year. It's reasonable to assume that she'll get 3% annual raise. So if her income goes up by 3%, her contribution to her retirement fund will also go up. So in year 2, she'd have 2,200 times 1.03. Good? What's the future value at age 62? Now, if you don't want to drag down through 40 years of cells, there is a formula you can use for this, but it's not an Excel formula. How to drag. Any answers yet? This is how I would set this up. And this is how I would think about these kinds of problems. Start with that first part that I mentioned, which is 22 now. And as soon as I see something about our 23rd birthday, I'm writing down the age. The 22 and year 0 are the same. Year 0 means today, and she's 22 today. And then starting at 23, which is the first year of our cash flow, we're going to put away $2,200. We're investing it. Money's coming out of our pocket. It's a negative. Next value is the previous value times 1.03. I didn't include a second column this time.